right, so trigonometric equations. Trigonometric equations. This is when you're actually solving for missing angles. Let's look at a simple scenario where I've got sine of x equals 2/3, and I want to find the value of x. The first thing I'm going to do is I'm going to move sine over. It's going to become shift sine on a calculator to find the angle. And then obviously grab a calculator and type it in. All right, so we press shift sine 2/3, and we get the solution 41.82, three significant figures, degrees. That's gonna be the first solution. I'm gonna call it x1. Now the second solution we know is gonna be 180 degrees minus the first solution. So I take 180 minus 41.8, and it comes to 138.2 degrees. Okay. So if we look at the whole concept of the graph of sine, I'm going to do a quick sketch here. The graph of sine starts at 0, 0, 0, and it works its way up, down, and goes back up this way. Yeah. The moment I find a solution, let's say I draw a line through this and I find a solution, you'll notice that it always cuts 2 points. So having cut 2 points, my first solution becomes x1 and my second solution becomes x2. But this is actually symmetrical in its design. So we've got the left-hand side over here and we've got the right-hand side over here, which is exactly symmetrical. From 180 degrees going left is exactly the same amount from 0 going right. So 180 minus that same distance over there gets you x2 every single time. So the sine in particular, only sine, would have solutions of x and 180 minus x, or whatever if you want to call it. The cosine graph will be different. Let's have a look at an example like that. So let's suppose I've got cos of x equals to 1/√3. So x will equal shift cos 1/√3. And now shift cos of that, you type in a fraction, you got 1 divided by √3. It becomes 54.7 degrees. But the second solution for cos is 360 minus the first solution. So we take 360 minus the first solution, 54.7, and it comes to 305.3 degrees. So the other option is negative. So this can be the negative of the first. Now I'll show you why. Let's see if I got the graph drawn quickly over here. Probably going to need a negative space as well. So there's the cosine graph. And I'm now going to start from one side over here. The cosine graph, bell-shaped, and I'm going to put a negative part as well to it, more or less, hopefully. Yeah. And then I'm going to draw a line straight through here, giving me all those different possible solutions there. Okay, so here we go. This first solution over here is going to be x1. Now, again, by symmetry, the second solution is over here. It's the same distance. So if I had this area until x1, it's exactly the same area on the side. So the second solution would be equal to 360 degrees minus the first solution, which the graph stops from there to there. So that distance is the same as that distance by symmetry. Now there's a repeat solution. If I go all the way back over here, I have another solution which is in exactly the same part of the wave, you could say, but 360 degrees earlier. So in this solution, because this distance is the same as that distance, this is going to be negative, the negative of the first solution. So if I have this answer, I mean, this is within a positive x value. If I'm allowed a negative x value or given the option of a negative x value, then it would depend on the restriction or the type of question. We'll have a look at it in a bit. But we have the option of having negative x. Okay, let's go to 10, and then we'll go to slightly more, not difficult, but a little bit of added information questions. Suppose we got 10 is equal to 2, shift 10 equals 2. So shift 10 of 2, 63.4 degrees. And that's when you're dealing with the tan graph. You only have one solution. Tan graph would do that and repeat itself. So if you had to have some value 2 on your y-axis, it would shoot out a single value, 63.4. There's no symmetry. The next value would be 180 degrees later or 180 degrees prior. All right, let's pick it up a bit now. So let's say I got y equals to, sine of x is equal to root 3 over 2. But I'm told that x is within a restriction. X can be anything from negative 360 degrees up till and including 360 degrees, let's just say. And I want to find all values of x. So the first thing I'm going to do is move the sign over and get my first value using the shift button. So shift sign 3 over 2, root 3 over 2. And it'll come to 60 degrees. All right, so x is equal to 60 degrees. That's our first solution of sine. Now let's have a look at the graph so we can get a really good indication. Now I'm going to have a graph that's going to cover from negative 360 up till and including 360, which means I'm going to try and do this free-handed. Let's see if I can get this done neatly. So there we go. Almost good. And this way, sort of getting there. No. There. Okay. Negative 360 degrees on this side, positive 360 degrees on this side, and I've got the solution x equals 60 degrees, which is around here somewhere because 90 is the turning point. So that's going to be a solution here. If I draw a line of all the possible solutions within this bracket, it's going to be basically wherever it cuts over there. And using symmetry and all the possibilities of it, I can see that definitely this one over here is going to be 360 minus 60, which is 300 degrees. I can see now a repeat solution. If I go from here to from the left hand side to that side there, I can subtract it. I can subtract 360 degrees. It repeats itself every 360, and that solution will come to 60 minus 360, which is negative 300 degrees. The solution repeats itself from there. So then I would take, to go from there, I would take 300 minus 360. 300 degrees minus 360 degrees, because that's repeating itself, is negative 60. That doesn't make sense. All right, let's double check that. So just double check this 1 second before we continue, just to make sure this works perfectly. All right, So from here, I've got to add 360 degrees to get back to there. That's 360 over there. So yeah, 360 is going to be there. All right. There's one mistake I made here. Can you see what I did? Exactly. Exactly. All right. So when would you use 360? Only when you're dealing with cos. All right. Perfect. All right. Silly mistake. All right. Yeah, you'll probably never forget it now as well. So let's go. We're going to go 180 minus 60, which is going to be 120 degrees. There we go. That makes so much sense because negative 60 is way out here. Negative 60 would have been there somewhere. So that makes sense. Now we can complete this. This is going to be 60 minus 360. Definitely had the 300, but in the wrong place. And this one's going to be 120 minus 360, which is negative 240 degrees over there. So that's going all the way back to there. That's going all the way back to there. So what are my solutions for x? So therefore, x can equal negative 300 degrees within this frame, negative 240 degrees, 60 degrees, and then 120 degrees. And it cannot go further than that or higher than that because it will then cross the 360 mark. Okay. So that would be on a restriction basis with the graph. Let's suppose I'm in a scenario now where I do not have the graph. Okay. And I want to do this without the graph and just on a calculation basis. The quadrants for reduction formula. Yeah, I think, yes. All right, we'll have a look at that as well. So, but x equals 60 degrees, and I know that by definition, the second solution is going to be 180 minus 60, which is 120 degrees. All right, so that's x2. And then because it repeats itself every 360 degrees, I can add 360, but that's going to be too much. So let's subtract 360 and then get the third solution, which is negative 300. And likewise here, I can subtract 360 degrees and get negative 240 degrees. So that's on a calculation basis straight away. If I have to draw this in some kind of quadrants, I know that 0 is over here. This is the cost, so AST. And 60 degrees is over here. I know that if I add 360 degrees, I'll go all the way back there. So in other words, 60 from 0 is negative 300 in the reverse. That's how we would get those two solutions. And the other possibility is using reduction formula, because sign is positive in this quadrant, we know that we would get a solution of 120 degrees, which would provide the same value of y, root 3 over 2. And so that's a possible solution. And then obviously going in reverse, that'll be negative 240 degrees. And that's how we get those two solutions from there. Okay. This builds onto the concept of a general solution. We apply cosine, exactly the same principle. Let's have a look at a cosine one. Let's just have a look at a cosine one anyway. Okay, so I've got cosine equation. I've got cos of x is equal to, let's say, root 2 over 5. I'm going to use a calculation, and the concept for the two solutions for cos is x1, negative x1, or x1 and 360 degrees minus x1 as possible solutions. So shift cos of root 2, and I'll give it some kind of restriction now in a bit. So root 2 over 5 will come to 73.6. 73.6 degrees. Let's suppose x is got to be, I don't know, greater than or equal to 90 degrees, but less than or equal to 360 degrees. Let's give it a bit of a weird one, and let's see what happens. So this is going to be x1. So that's going to be my first solution, and that's going to be my second solution. All right, could label this anyhow. Let's go to the negative of this as a possibility. So negative x1 is going to be negative 73.6 degrees. Yes, that's in the range. And then we take 360 degrees minus x1 to get x2. So x2 would be, this is, we can call this one x2 even. I don't know, I'm just labeling it x2 and x3. But x3, you're going to get 360 minus x1, so 360 minus 73.6 will definitely fall in this range as well. So if I draw the cos graph and I end up with 73.6 here, then exactly the same distance to the left of 360 degrees means that I'll take 360 minus 73.6 degrees to get there. So if I take 360 minus 73.6, it'll come to 286.4. So 286.4 degrees. Okay, so that's going to be the two solutions. Now, there is a possibility of having maybe another solution. Let's see, maybe. All right, if I draw it like that, I can only see three solutions. 1, 2, and 3. So we might just be done here. If I have to subtract 360 degrees, I will end up there. And if I have to add 360 degrees, I will go over that requirement. So that will be my final solution. Okay, let's look at, yeah. All right, let's have a look at general solution now. The general solution is a formula, or it's something that provides all possible solutions. All possibilities expressed. All right, so if I go sine of x is equal to root 2 over 2, and I say shift sine of root 2 over 2, (45 degrees), special angle, and this general solution we know is going to be all the possible solutions. So this is going to be the first one. The second solution is, remember, 360 minus 45, which is 315 degrees. Then what we do is we add a factor of 360 degrees to both sides, or subtract. And this is where k is simply some kind of integer. And if I substitute 1 in there, it'll add a factor 360 to 45 to get the next solution. I put 2 in here, it'll double it up. So in other words, if my graph is doing that, and I've got 45 degrees, which is over there, and I add 360 degrees, I'll end up over there, and then 720 over there. So this would be 1 times 360. This would be 2 times 360 added on to the initial 45. Yeah, and then it can go in a negative direction as well. That's why we have the plus minus, right? So infinite, it's an infinite amount of solution, all possibilities expressed over there. The cosine graph follows the same thing as well. And I mean, yeah. And this is, again, I made the same mistake. Exactly. Thank you. So, yeah, once you remember that, you'll be good. So 180 minus 45 is going to be 135 degrees. It makes more sense. Plus 360 degrees. And that's good. The cosine graph will be 360. Same concept, but yeah. And then the tan graph will only have one of those. All right. So at some point in time, we can actually write this together. We can go sine x is equal to some angle b. So we can say x is equal to shift sine of b. Two possible solutions. 180 minus or we can just say x is equal to x1 plus minus k 360 degrees. K is an element of integers, and x is equal to x2 plus minus k 360 degrees. K is an element of integers, and the second solution is 180 degrees minus x1. Now I'm using degrees here. You'll find that we've got to also become eventually accustomed to using radians, in which case that'll be 2 pi over there as well. And then the sine graph repeats itself in the same manner, but 360 degrees later. So, I mean cos graph. And that will then change for the cos graph to be 360 minus x1, etc. And your tan graph, yeah. So for the tan graph, it would be 180. So we got tan x is equal to d. Then x will equal x1. I'm not sure what fraction d is. It's going to be plus minus k 180 degrees. K is an element of integers. So we can go through that in detail. Now, so the only difference here is that we're adding factors of 180 versus 360, and that's where, and there's only and it's going plus and minus. All right, it's going plus and minus because you can go back and forth. So this is going to be that there, and you can see that if that first solution is there, the second solution will be lying approximately 180 to the left, next one 180 to the right, and factors of 180. So k is an integer. So for general solutions. Now let's look at another form of a trigonometric equation where we actually have this concept in here. So you got sine 2a equals 3 over 5. In this case, I would first find the solution, the first solution, which is should sine 3 over 5, which comes to 36.9 degrees. At this juncture, we do not divide it by 2. We do not divide it by 2. We express both solutions first. So 2a can equal 36.9, and I'm going to use a general solution, plus 360 degrees. K is an element of integers. And then I write 2a again, and I know that the second solution, let's see if I can remember it this time, is 180 minus 36.9. And that'll come to 143.1. So now, after I've done this, then I divide everything by 2 to get to the final general solution, which means the application of dividing by 2 has to also be applied to the 360 at the end here. And so that becomes supposed to be plus minus. Yeah. So this will be, so this is the first solution. And that's the second solution. But we're also looking at a general solution. So that will be 36.9 divided by 2. And that's equal to 18.45 degrees plus minus k 180 degrees. K is an element of integers. General solution done. For this one here, 143.1 divided by 2. So we know that, just to go back there to the two possible solutions, we know that at any juncture, if sine x is equal to some fraction, we know that x1 would be itself, but x2 would be 180 degrees minus x1. So this would actually technically fall into x1, and this would be 180 minus x1. Yeah. And we apply that first before we divide everything by 2, and that's where we would get to that part. So, okay, so 143.1 divided by 2 comes to 71.6 to one decimal place, plus minus k 180 degrees, round according to whatever is required, and that would be my final solution there. So k can now be added and subtracted, and this is a general solution. This is a general solution concept completely, right? So if at any point in time I need to find specific solutions within a range or within starting and ending values, so I'm starting from 0 degrees and I get to some value of angle A and it must be less than, I don't know, 400 degrees. Then I've got to take my calculator and keep adding 180 and factors of 180 until it's out of range for each of these as well. And then I could then get all the possible solutions. But yeah, in this, if they ask you for the general solution, then you don't need to provide specific solutions. You just need to provide a formula like this. But if they give you some kind of constraint on x, then you have to then you just replace k with plus minus 1, plus minus 2, plus minus 3 until you're out of range for each one. And then you might get 4, 5 solutions, 6 solutions, especially in a question like this where you end up with a smaller angle and you're adding and subtracting a smaller factor of k with k in it. You'll get more solutions than if you did that without dividing by 2 part. All right.